This is part 5 of factoring expressions of the form of x squared plus bx plus c, part 5. Okay, so let's start looking at our example. And in this example, we have a quadratic equation, as you may have noticed. We're calling this an equation, right? And basically, it's called an equation because the y value depends on what the x value is, right? And just like linear equations, you can give us a certain range of x values, and with that you can calculate the y values. You can plot this data, and when you plot it, you will get a parabola. Now, I would also be providing some links on your screen, so I'll try to put it I don't know, somewhere around here on the screen. I'll try to put them there when you watch this video, so you can actually try and put these put this equation and see how it looks exactly. Alright, so the first question, it says A, factor the right side of the equation fully, right? The right side meaning the right to the right side of the equal sign. So let's factor this, right? First thing when we're factoring, the first thing that we do is let's find a common factor. The greatest common factor among all these three terms is essentially, I'm not going to rewrite it, but it's looks like it's 3, right? 3 fits nicely into this one and into that one as well. So let's factor out the 3. So 3, open bracket, this becomes x squared minus 10x plus, I believe that will be 16. Alright, good. So we have factored out the 3. Right? Now we end up with a simple trinomial here in the bracket, so let's factor this one out. So let's factor this expression fully. Right? So we're looking for two binomials that will give us that expression, so x times x to take care of the x squared. Now two numbers whose product is going to be positive 16 and the sum will be negative 10. So they both have to have the same sign since the product is positive, and since the sum is negative, then let's make them both negative. So negative times negative, positive, right? What two numbers will give us 16? Well, first one I could think of is 8 times 2. And yes, that works out nicely. So 8 times 2 gives us 16. When you add these, minus 8 plus minus 2, that gives us minus 10. So that's it. So these are the two numbers we're looking for. Now, question B says to find the x-intercepts of the parabola, right? To find the x-intercepts of the parabola. So this is just a general example, right? In the next unit we'll see this in more detail, but just to give you a rough idea, right? The x-intercepts, we said, are the points at which the parabola will intercept the x-axis, right? So let's do this a rough sketch here, right? And if you recall, right, some videos ago, right, these are the x-intercepts. These are some rough sketches of parabolas. This is an x-intercept where it intersects the x-axis, right? This is also, right, it's intercepting the x-axis, right? So we're looking for these points now specifically, right, they're asking us to find what these points are, right? So far we've learned how to factor this, right? And we get to this point. Now when they ask us to find the x-intercepts, all we have to do is we take the stuff that is in brackets, right? Or wherever there is an x, right? Like in this case, x minus 8, and we set this x minus 8 equal to 0. So x minus 8 equals 0. When we solve for x will be equal to 8, and here x minus 2 equals 0. What would be the value of x when we solve it? X would be equal to 2. Okay, which means the following, which means that if we were to graph this, let's move this up a little more. If we were to graph this, right, and this is a rough sketch, I will show you actually a more accurate sketch in a second, but just want to emphasize certain things here. We're looking at this. We're saying, if we're saying that these are the x-intercepts, we're saying that the parabola crosses the x-axis at 2 and at 8, right? So in fact, let's draw this. So far we don't know how far down it goes, but we know that it crosses 2. Okay, that's a pretty Good rough sketch, not too bad. So we know that it crosses at 2 and at 8. These are the x-intercepts, right? Now, how far does it go? We don't know, but we will soon be able to find this out. The next question says, find the equation of the axis of symmetry. So what is the axis of symmetry? Is basically the point that is between, that's halfway between the x-intercepts, right? So how do we find that out? Well, we simply add the x-intercepts and we divide them by 2 in order to get that. So let's add the x-intercepts. So we add 2 plus 8 divided by 2. That gives us 10 over 2, and this is equal to 5. So x equals 5 is the equation of the axis of symmetry, right? Which means is this point right here. So, right, this is the axis of symmetry. Right, so, and we've said that this is 5, right? And so if we know that this is 5, we know the following as well. The next question says, find the vertex. Now, what is the vertex of the parabola? Let's move this up a little more. The vertex of the parabola is the following, right? The vertex is basically either the highest or the lowest point of the parabola, right? So let's put here vertex. And in fact, let's bring this up. Again, this graph, right? These graphs over here, the ones that we had seen before, right? What is the vertex on this one? Well, on this one will be the lowest point, right? That will be the minimum point. The lowest point of this one is the vertex, right? That will be the highest point of this one. The highest point of that is the vertex, right? So when we're looking for the vertex, we're looking for the coordinates of those points, right? For the coordinates of these points, right? Same thing here. We're looking for the coordinates of these points, right? Same thing over here, the coordinates of these points, right? Okay, and in this particular example, we are looking for this point, right? So far, we've got one information here. We know that the x value of this is going to be 5 because we got that from the axis of symmetry. But what about the y value? How low does it go? Well, all we have to do is, since we know the x value here, all we have to do is substitute it into our formula. Now we can substitute it either, we can substitute it into the equation, or we can substitute it in the factored form. Let's use the factored form since we're dealing with factoring in any case, right? So let's look at that. Let's move this up a little more. Alright, and let's see. So we're going to substitute it into the equation, and we have the following. We have, what is our y equals 3 times, and let's substitute the 5 that we obtained here, right? So I'm going to write down 5, right, minus 30 times 5 plus 48. Well, in fact, you know, we can do that, we can solve it as well, and we should get the same answer. Now, if it makes it easier, as I said before, and you can also substitute it in the factored form, right? So in fact, we can have 5 minus 8, and then 5 minus 2, right? And that would also work as well, right? So either or, it will work, right? Or, right? Well, let's use this one, right? The one on the factored form. So basically we get 3, what's 5 minus 8? It's minus 3. What's 5 minus 2? 3. So the answer of this will be negative 3 times 3 times 3, 27, right? So this means that this is our y value. So the coordinates of the vertex are, we already know that it's 5 because we saw this here, right? It's minus 27, pardon. Okay, and we already know that the coordinate here is 5 already, right? So let's substitute this with negative 27. So that means the coordinates of the vertex, right? Therefore, right, our vertex is 5, comma negative 27. All right. And of course, the last question is asking us to graph this, right? But what you can do is you can go to the links that I'm providing you on the screen, and you will get this. You can go to either one or the other to see, right? So here we have our x axis, our y axis, right? Here, let me just rewrite it here again so we can all see that's the y axis, right? You can also see how basically, well, this is our y equals 3x squared minus 30x plus 48 equation that has been drawn here, right? We can see, as we found out, that these are the x-intercepts at 2 and at 8, right? We can also see that the axis of symmetry is right here. And in fact, I just want to use a ruler here to indicate what the axis of symmetry is. So this is basically to wrap it up. Right? And we can also see that this is our vertex, right? What are the coordinates of this vertex? Well, we pointed out that the coordinates, let me move this up a little more. We pointed out that the coordinates of this vertex are essentially 5, comma, negative 27. These are the coordinates, right? And you can see how this also is there at negative 27. Okay. That's all. Work on your homework, and we'll meet next time.